If you click on week 2, we already did the Kahoot. Solo learn, I'll just go over it. Some of you already finished that. Majority of you have. I know some of you have done other languages in here, which is great. If you haven't downloaded the mobile app for Android or iOS, I recommend it because it's a lot simpler to do. It's in your hand. You can do it while you're waiting on something. Got multiple languages to learn besides what you're learning this semester. And so a number of you have already completed a number of languages. One I'd recommend definitely be Python. That's a good language to learn. Even though we don't teach it here on campus, I'm putting in to teach a boot camp for Python. In this classroom, we teach a lot of boot camps in May. I teach a lot of boot camps in May. It's 4 Saturdays, like iOS and what we've done so far. We're going to do another iOS in May, but then the following May, we're going to be doing Python. And Python's a really popular language for gaming, mobile apps, desktop, laptop, mobile, anything, manufacturing, robotics. So on this one, is solo learn for this week is the conditions and loops. Finish all of them. Make sure I see that they're all checked. You'll submit an upload as always when you're done with the screenshot. Chapters 4 through 6 on the modern C++, that is the online reading. The 5 through 7 practical C++, which the review questions come from, and most of your weekly Kahoots will come from. That's a PDF download. Hopefully you download that to your device. That way you're not bringing bandwidth down while you're in classroom. We won't be technically accessing that in class anyway. But I do recommend putting it on your tablet or phone, that resource. So both of them are good resources too, by the way, to have. Slides today, we're going to go over 5, 6, not 7, but 5 and 6. 7 goes over compilers of GCC. I threw that in there just in case some of you might want to play with that and do your own compiler install of GCC, which is GNU Privacy C++. You don't have to, but some that really have extra time on the weekend want to stay up all night Saturday and Sunday, maybe you want to do that. Okay, it's not real hard to do, but anyway, it walks you through how to do that. So we're going to go over chapter 5 and 6 real quick, just a cursory look of the slides here, and these are available for you as well. Hopefully you're going through these. And again, you don't have to be in depth on the slideshow, just kind of overview. That's what I recommend. That's how I did it when I was in school. Things of interest. So this one's arrays, qualifiers, reading, numbers. And again, the first few weeks of this class is just a refresher of C++ to get you started again. It's been a while. As we get past the intro stuff, you'll be getting more into what really C++ Advanced is about, which is classes, polymorphism, and using classes throughout your program by the end of the semester. Because classes are really where the power of a program comes in. And so hopefully by the end of the semester, you'll have a good understanding of what a class is, how to use a class. And we will start out classes in baby steps. We start out this week in your reading in classes, and then keep going in more advanced as the semester goes on. One of the components we'll go over in your assignment this week is I'm adding in a challenge each one of your assignments that you can do. You're not required to do, but if you want to do for extra credit and just to kind of challenge yourself, I recommend that. And so when you do a challenge, I'll see it in your code and when you submit it and give you extra credit for that. Right now, I'm going to give you like 10 points per extra credit assignment for each week, just to kind of a little something for doing it. The review questions that you answered for week 1 will be available in the bottom module. I'm going to put in there for solutions for your reading review question solutions. That way you can match it with yours. So arrays, by the way, week 1's already been graded. If you have yet to turn anything for week 1, I'm still accepting stuff for week 1 because of the MLK Day and just to be nice, to make sure everybody gets 100% week 1. So if you've not yet turned anything for week 1, like if there's a few people that still had not yet put in an About Me, if you have not done that, please do so. And when you go to the About Me, if you've not done anything, you won't see anything, meaning you won't see anybody else's comments. All the discussions this semester, you know you haven't done it if you don't see any comments whatsoever, because you don't see any comments, so you posted one yourself. Does that make sense? And so make sure you do that. So an array is basically, in mathematical terms and in programming terms, a values or set of values that start with the zeromost number, the number 0. Now, an array can be made up of strings. It can be made up of integers, booleans, images, videos, pointers, classes, other arrays. Now, it gets a lot of confusing when you start doing arrays of arrays, but you can do that. And so, but arrays simply is to help you manage data input and output for the most part. So when you're creating a program to, like, say, do a grade book, and you have 20 students to enter a grade, it'll go through an array of all those 20 students, put in the grade letter for all of those lessons for that student, and then at the end, save it to a database with that array. So arrays are real popular and real powerful because it gives you the power to iterate through one variable name multiple objects. So when you're, like in all C++ programs, starting with your main to kick off on any type of program, you want to start out with a string variable. Say if you're using a string input with a CN, or including the standard input as well. This slide looks terrible. And concatenating strings as well, which we've done that already. The slide will look better. So when you're entering in basically a substring, which is basically a string of a string, and you're searching for a string, you've got str.substring first last. str, this is a test, str.substring 5 of 6. Basically, it's going to kick back out of there up through 1 through 3 on the output. The string.length just finds the length of the string. And then this std, anytime you see in your reading the std : you normally don't have to mess with that nomenclature in programming because you're putting that on your input statement, the standard input standard statement. If you don't do the input standard statement, which years ago when I started programming, we couldn't do that, so we had to put that on every one of our lines of code. We don't have to do that anymore. A lot of your text will still have it. So when you want to access one of the characters in a string, here's an example of getting the 6th character. Remember, array starts with 0. So you have 0, 1, 2, 3, 4, 5. So we have 6. You're accessing the 6th character. We'll not check to see if the string has 6 characters. It just assumes it does. If it doesn't, it's going to blow up that line and tell you that array index is not available on the compiler. Better and much safer, getting the 6th character aborts a program if there's no such character using the str.at symbol. So it's not available. It does a soft exit and does not crash your app. One of the ones I recommend as we go on and using arrays, though, is doing loops, iterations, and doing when loops and while loops to determine if a next is available on an array as well. That helps as well to determine the count, more so than trying to guess what the count is, especially on database entry type of stuff and database type of programs. When you're reading data, this is a no-brainer for you, but CN, cout for output, for writing something to the screen or to some device or to some database. CN for reading data. And so we did a CN price, number on hand. Numbers would have to be separated by white space, which really isn't good. It's good when you're learning C++, but for a real program, it's really not good design to have a user have to enter a space to enter in anything. It's usually good to have it per line type of thing. But this does show that you can do that. And if you have a user have to enter multiple values separated by space, make sure to put that in the definition of a cout beforehand. Please enter number separated by space, something like that. But again, while you're learning how code works or you're being refreshing yourself these first few weeks, it's okay if you just do it like this to where you just get your head wrapped around CNs again. Numbers are separated by white space, like spaces, tabs, or new lines. For example, if our input is 32 space 6, price gets 32. Number on hand will get 6 because it's separated by space. So if we enter the value of 12 twice, 12 is 24. So with Well, let's go to the reading strings one. When you're reading strings using a standard CN, works fine for integers, floating point numbers, and characters. Does not work well for strings only. Most of you are familiar on the CNs for inputs of user keyboard, right? But in the past, strings could be entered, or CN could be entered by a string variable, which can a lot of times skip a line and crash a program, so don't recommend it. CN generally, for our purposes this semester, will be input from a keyboard for that CN, which we look at some examples tonight, and your homework actually has some examples of CN. So initializing of variables, integer counter 0 is the number of cases counted so far. Int counter equals 0, the number of cases counted so far. So you'll notice C++ and CC language, which is a precursor to C++, a little bit different. Array initialization, you can declare array as empty, like a int product codes 3, or declare it with objects in those or values. Like in this case, we have 3, and so then we do 10, 972, and 45. Dimensioning of array, you can actually put in here with brackets, an empty array, meaning you could add multiple numbers that you need to add for that array, which a lot of times is used in manufacturing or in calculations where you don't know what the number might be. The number n might be something that is questionable on multi-dimensional. Yes? This here? This one here?
Where it says int
counter 0. No, I don't use it much. That's a new initialization. I still don't personally use it much. You'll see in my examples I don't use it much. You can still do it, though. You can definitely still do it. As far as preference, I do not use it. I personally do not use it in my daily coding, the new initialization, because the old still works. And old habits die hard. So, but you could use it. You could initialize it as a new initialization is with the parentheses around the value, for sure. And I don't prefer either one, personally. As long as you're initializing values, it doesn't matter to me. One of the things C++ will not check for is bound errors in some things. Like an example of an array int 5, data 5, result equal data 99. Well, that's just an arbitrary number put in the array. So how did that come about? I don't know. So it's just bad programming just to arbitrarily put a number in without having some type of check sets beforehand. Very bad here will be, besides just calling the array data 99, the next one here actually tries to populate and initialize array data with the 99th index with a new value. That's even worse. And so C++ will not check for this. And so again, programming logic has to accommodate that, and you'll learn about that this semester. I'll help you with that this semester and wrap your head around good logic and bad logic, and how to stop or how to debug your application to stop things like this from happening. And again, it's just a lot of programming, as you already have learned in your journey as a coder, is trial and error anyway. And so and that's not a bad thing. That's a good thing. And so one of my best quotes in programming is, programming is learned through difficulty of projects. So what that means is the more projects you get under your belt as time goes on, the better programmer you become, just because of the sheer nature of programming projects you've completed, right? Which makes sense. Like the more surgeries a surgeon has under their belt, hopefully they get better as a surgeon as time goes on. Same thing as a programmer. Learning standpoint, as an instructor, I want to make it as easy as possible to gather data and information to where you have time to play with the program and manipulate it and add things to it, because that's when you really learn. That's when you really remember things. If you're crashing to get a program work and you spend, I did this in college, I did this, you guys have done it too. If you're crashing for 2 or 3 nights, staying up all night to get a program completed for a project, at the end of that program, when you submit it, if somebody's asked you next day, what'd you do on that program? I don't know. I had no idea what I did. All I know is it worked and I submitted it before due date, right? That's great for a grade, but it doesn't help you become a better programmer, because when you go out in the real world to become a programmer, and I've been programming for 28 years, and I've been to a lot of classes, and like you have in programming, and I've learned how I learn. I try to teach the way I learn, which is as many resources available at your fingertips to help you learn. Whatever examples I can give you, whatever helps I can give you, whatever podcast I can give you, and at the end of the semester, you retain it and understand it. That to me is more important than getting one program complete each week and getting a good grade, if that makes sense. All right. Comprehension is important to me. That's how I teach. And so anyway, hopefully that'll free you up, though, to be more creative, though, in your programming endeavors. And be able to play around, too. That's important, too. Play around with your coding, play around with your programs, and hack around to figure stuff out, because that's how you learn. And that's how you learn. And so the assert function in C++ is basically checks to see if a condition is true. If it's not, the program can be aborted. And so assert function is kind of newly used. Maybe some of you not seen it before. We'll be using it throughout the semester. And some of these things we're going over, these chapters here, are maybe something you've not went over before in the beginning C++. And they're going to just I'm just going to go over them. And then as the semester goes on, we'll be utilizing them. And we'll be like, oh, yeah, we talked about that. In week 2, we talked about that. We saw some examples of it. And that's another way I teach as well. Instead of you learning something now and then immediately having to complete something on that, sometimes isn't the best because it's overload, information overload. I'd rather start out small. And if you want more, let me know. I can give you more. I have a lot more to give you. I can give you a lot more. But hopefully you take advantage of the leeway and the freedom of investigating and having fun with your code. Does that make sense? Okay, so asserting on protecting arrays. Again, the only thing you need to learn about assert is it's kind of like a beefed up if statement. Okay, it basically validates indexes in this case, or arrays in this case. Like here, assert index is greater than 0. And then the next one, assert index is less than 5. Not the best way of doing it. And then index, date index, if you're doing like a for loop on index, which we generally do. Some of these terminologies also, too, we'll go over this semester, which is size of, which automatically computes the array limit. So it determines the number of bytes in an array. That's important when you're dealing about large bits of data, large chunks of data. An example is if you have an array that is an entire contents of a SQL database table, okay, that could be quite large, right? So you can determine what size you want, what size you're allowing in an array too, to where you're being more, even though our computers have more memory than they had when I first started, it's always good. It's a good idea to be a good steward of your memories, memory systems that you have and you're working with, because it's like a montage, right? We have a montage of systems. We have, some of you might have, 12 gigs of RAM with 2 terabytes of hard drive space. And then we have some users that are using Chromebooks that are barely screeching by clicking on a link. And so we have a whole spectrum of users out there that could be developing your, playing with your apps, whether it be a game app, whether it be a utility app, whatever it might be. One of the things hopefully I'll be a time to teach you this semester as well is interoperability of your code, meaning when you create a C++ application, it's always good, I believe, to also say, okay, I know how to do it now in this program, C++. I'm going to now apply it to Python. I'm going to apply it to PHP. I'm going to apply it to Visual Basic. I'm going to apply it to iOS. I'm going to apply it to Android. I'm going to do the same program in multiple different dimensions. And if you're interested, I'll give you tools this semester to play with that as a playground. It'll be a playground area I'll add in each week where you can do that very thing. Take your code, compile it in C++, and then be able to do a transliteration of that code in other languages. Okay, and transliteration basically means taking whatever language and translating it into another language. It can be for dialect. Like when I was in Bible college, I have a theology degree, I took Greek, and we had to do 5 hours of Greek every day for 5 days for 2 years. It was nuts. But thankfully, the teacher was very animated. And one of the things you learned in Greek was that every root word of every English word, the root of every English word derived itself in some Greek word. And we would take that etymology of that word and spend weeks on one word and dissect it in multiple different languages besides Greek, like go into different dialects like in Asia and China, and then try to figure out what they meant in those languages. But what's cool though in that whole process was, and it does apply to programming, is that everything can transliterate into something else that you're learning. And why not learn whatever that is, right? That way you're just broadening your horizon of learning, and you're broadening your horizon of knowledge to where you're more versatile as a programmer. And it's more interesting too, I believe. That way you're not set just on one standardization for programming. You can actually branch out into other as well. Because, C++ can only run in certain environments as an executable. But if you morph it into a web app, and to a Python app, and to a PHP app, and to a JavaScript app, it can run on every different type of environment, right? And so hopefully this semester, the playground that'll help you understand that more. Multi-dimensional arrays, hopefully you got a little bit into that into the first C++ class you took. And multi-dimensional array we'll be getting into this semester for sure, and more depth. But basically, a typical matrix of a multi-dimensional is the brackets. How many brackets you have, sets of brackets determines the dimensions of that array. You have a 1 dimension, a 2 dimension, a 3 dimension, so on and so forth. Now, the more dimensions you get, it looks fine on that linear line of that matrix line. But where it gets touchy and sticky is where you have to start breaking that array apart into multiple for loops or multiple nested for loops. That's where it can kind of hairy. And I know you've done a little bit of that. This semester, I'm going to show you ways I've learned over the years to, I call it beautify your code, to where you can beautify a multi-dimensional array to be more manageable for you as a coder. And not only for you as a coder, but for those of you that come after you to take your code on a project you're working at work and be able to make sense of it and to add to that code. So C++ doesn't follow notation using other languages like a matrix, like, the comma separator, which a lot of languages do. Some I already mentioned do. Python does. JavaScript does. Even Java, in a sense, does. Kotlin, the new Android programming language, it does. Swift, the new iOS language, it does. And so all these languages do follow notation. C++ doesn't. It's because it's more of an old school language. It's right after C was C++. And so it's been around a while. They have changed some things in the modern C++, but there's still going to be some old school things as well. So here is a 4-dimensional array at the bottom of this slide at 10, 12, 9, and 5 dimensional. So it'll be a 4-dimensional array initialization there. And one of the things I'll mention on initialization, I don't know how much we'll spend on initialization on intro, but we'll do a lot of initialization this semester on not only variables, but since we'll be playing a lot with classes. Classes are important to be initialized because of the scope of a class can be both local and it can also be a class that is global in nature. By nature, the classes are global in nature. So you have to be real careful on your initializations and naming conventions of your variables and things of that nature. This one here won't go over. C style I won't go over. Nope, that's it. I want to go over on that. The rest of it on C. All right. Chapter 6, decisions and controls. This basically is just decision making on programming. Whether you're doing a linear or multi-dimensional, you're going to have some conditional clause. An if clause, a when loop, a while loop, all throughout your applications, right? And you should have. Beginning coders should learn conditional clauses and looping and iterations early on to say, well, it saves time. It saves time in coding. If you can learn looping early on and learn iterations early on. If statement's the first one that talks about in this chapter, which is just a note of, again, rules in C++. Every if statement begins in lowercase and ends in lowercase. It is after that if statement a parentheses with a statement in it. So an example, if total underscore owned is less than 0, the C out is you owe nothing, new line. Another new one that I would recommend using, that some of you already use, instead of the new line, you can do the two lesser than symbols and else. That's what you'll see in the working world used a lot still today. That one works on new line, but that's what usually programming standards is, instead of using the /n, it is the two lesser than symbols and else, semicolon, which you'll see that in all of my examples pretty much this semester. Even though textbooks will give you stuff like this. Not that it won't work, it's just it will work. It's just there are what's called programming standards for all workplaces like Sunstrand, all these, NASA, Google, Apple, all these programming standards, and L's a programming standard still for C++ on a new line. If you want another C in, another C out for sure, you want to end L. So it doesn't fall on the same line each time, multiple C outs. Relational operators, you're familiar with these, but just, again, a refresher: lesser than or equal, lesser than, greater than or equal, equal, not equal to. On a single char, remember it's single quotes on a single char. If you're comparing or validating conditionally a char, single quotes instead of double quotes. A lot of times that's used for programs that loop, either a Y or N or a Q for quit. The single char, which I know you probably did a few programs like that, at least one or two, and 76 for sure. Logical operators, the or symbol, you saw on the quiz, just a true expression. If both are true on both sides, or any side, if you have multiple ors, and everything has to be, on all arguments have to be true on or. At least one argument has to be true on the or. Logical not. This can be kind of confusing for new programmers, or maybe when you're refreshing yourself. It returns false if an expression is true. Returns true if an expression is false. So it's reverse logic. Anytime you see a not operator before any type of logic argument. But it is helpful sometimes, because that's really the only thing that makes sense sometimes on a program. This example here, if total underscore owed equals is lesser than 0, it's going to increment 0 count with a plus operator, the increment, and you owe nothing. Note the use of curly braces to group multiple statements together are treated as a single statement, which again, should be common knowledge, but again, just a recursor here, refresher. Else paths can be a statement, or it's at the bottom of usually it's going to be at the bottom of your logic. It's going to have no parentheses and just a default path. So nothing else above the if works, or if else's work. That's your default else path. Like, user not found, program exiting, bad input, whatever. Okay. An example here is if total owed is less than or equal to 0, you owe nothing else, you owe whatever the dollar amount is. So in this case, there is no argument needed. It's if this is true, this, else something, which is going to be the false path. Which if does the else belong to? And so on this one, again, aligning matters a little bit, but let's look at it for just a second before you read the A, B, and C. So the first line is if count lesser than 10. Second line, if count modulus 4 equal to 2. Seeing out condition white, else. The indention's wrong on this one. Condition 10. So A, it belongs to if number 1. B, it belongs to if number 2. You don't have to worry about the situation if you write the code like this. And so when you're going into if statements, the making sure things line up is going to be helpful. Okay, and a lot of your compilers will, like say, if you put your cursor in front of the else here, it'll show you the if statement or the if logic of that path. I recommend just, again, indentation is important, and you can do it in Notepad and then bring it into your program. like we're using the online version of IDE. So again, if you put some thought into your if statements, it's not going to be that difficult. It's where you try to do things maybe or rush yourself, which you make mistakes when you rush, and slow down, and you should be fine on multiple if statements. While statement is while condition is true, that statement's going to run. And we'll say it might be a entering grades example I gave earlier. While the teacher keeps pressing yes at the end of any grade, end of every grade entry, they go to the next student. When they say no or the end care, it exits that program. Okay. Or you're entering scores, you're entering whatever it might be, a shopping list, let's say. Shopping list, bread, yes, eggs, yes, milk, yes. And finally, end, you're done, and it ends the shopping list and prints it out or sends it to your phone or whatever the case may be. An example here has a counter operator, counter variable called counter with an initialization of 0. While counter is less than 5, it's going to increment total plus equals balance counter. It's going to increment that total initialization with that appended plus equal sign. And then the counter operator, counter value is going to be incremented by the counter plus plus each loop, each while loop. Fibonacci sequence, this one here basically is a mathematical sequence for 1, 1, 2, 3, 5, 8, so on and so forth. The terms are computed in equations as below. 1, 1, 2 equals 1 plus 1, 3 equals 1 plus 2, 5 equals so on and so forth. You keep going on down. And that's f to the nth power, f to the nth power -1, or f plus f to the nth power -2. And again, this is for the Fibonacci sequencing, which we do want a couple apps in this Fibonacci sequencing at the end of the semester, just to show you the power of that, of how it can be used. Execution of a Fibonacci is basically you got your current number, increment number, and then your next number and old number. That's how it's going to go through the equation. Break statement. This is important. Anytime you have any type of loop or case statement, case select, you want some type of break at the end of that. Within each, at least at the bottom of it, a break statement to break out of that loop and to break out of that sequencing programming that you're doing in the loop. Assignment operator, anywhere, side effect. C++, you can use assignment statement almost any place, and you can put it any place. I'm more of the school of thought of, on my programming in C++ anyway, to put my variables, as far as my global variables, at the top of my app and the int main, above the int main, and then I will then put my local variables within my functions. If you stick to that rule, you're pretty much okay. Anytime you want to put a new global variable, it goes to the top of your code, and local variable stays local. I also keep a running tally on a piece of paper or notepad or something of all my variables, just to make sure I'm not duplicating variables that have been used already. And a lot of times in my code, I'll put in and I'll just save a text file in the program folder called variables.txt, and then just have a running tally of it. I've done spreadsheets before in the past. Whatever it is you want to use really doesn't matter. Now, when you get larger programs, though, it can definitely get larger in scope. And so in those cases, I have done in the past like a spreadsheet with a variable name, and then maybe to the cell to the right of it, the description of that variable, and also to the third cell to the right of it, something like where it's found and what files it's found. That's helpful as well. Especially like a program we just did, just finished up in 2011, now has 1.5 million lines of code, a montage of C++. It's got some VB in there. It's got some JavaScript in there. And so that type of programming needs some type of, you may have heard of data dictionary before when it comes to SQL. This would be like a variable dictionary just for variables. So you can determine what variables have been used. And then that way, when I do leave that program with somebody, which eventually that will happen, they can take over and they can manage the program just fine and keep on what's been done with that program. So I guess a variable dictionary would be kind of a good way, as we mentioned earlier on the quiz, the quiz that we did, like comments. Variable dictionary would be a good way to also keep your program, future programming of your program in health. Okay, go with that, done. All right, now, next, I've got some examples I want to look at. And by the way, here's a podcast that we're recording today. There's a couple that we're missing. One was sick, one was for work. But anytime when you guys leave, you can go back to that week's module. The podcast will be being recorded of what we're talking about on the overhead. So you'll hear my voice and the slides. And you just forward fast to what you want to watch or whatever. You don't have to bore yourself with the whole thing. So examples. Let's look at some examples here together. I've got 4 examples, 2 arrays, a simple function, and a math function. Each one of these, or some of these have some challenges in it for you to do, to kind of play with. The first one is the arrays that we'll look at. This one here is a arrays as parameters. I have in here my include statement, my using namespace standard, and then my int main, which we'll look at first in lines 11 through 20, and then the function print array, which its job is just to print an array that's called to it. So let's run this app as it is, and then we'll go over the code, and then I'll give a challenge here for you to do, and I'll kind of walk around and help as needed. So go ahead and hit the play button to play this. So you'll notice when you play it the first time, it should kick out 5, 10, 15, and then 2, 4, 6, 8, 10. It has 2 arrays, first array, second array. The first array has the 5, 10, 15. Second array has 2, 4, 6, 8, 10. The print array function actually has in there 2 arguments. It has in there an integer argument and a length argument. The integer argument is an array itself here, as you note here, with the brackets. And so it's calling into this function an array that's an integer and a length that's an integer. And in the for loop, for n equals 0, while n equals 0 and n is less than length, it's going to keep incrementing that argument. So the first argument in the function print array is the array itself. The second argument is how many array indexes do you want to print out from 0 to whatever. Now, whatever is a wrong statement because you're limited in what you can print out, right? And this one is 3, and in this one it's what? The second one. The second array is limited to what? 5, right. Now, the other thing, too, you'll note on the array that you're sending and the argument, your arrays start with 0, but you notice on the array argument or the length, it starts with 1. So if you only want 1 to print out, you're going to have to send over 0. If you want 2 to print out, you send over 1, so on and so forth. And so 0 would be 1, 1 would be 2, so on and so forth as far as the what you're wanting to print out. So this one printed out 3. Now let's just play with this real quick. I'm going to have you change 3 to 1 on both first array and second array, and then recompile it and run it. Just to show you what I'm talking about. It should only kick out here the first 2 in the array, then the 5 and the 2 only, okay? Now, if we try to expand beyond that, like say I want you to go 4 on the first array, and I want you to do 6, we're going to break it. I like it. I like to break stuff. And in fact, I tell testers all the time, break my code. I want you to. And they do pretty quick. So, okay, that's what's going to happen. So let's go and play that and see what happens. Notice you get some weird stuff going on here when I try to go beyond the scope. Notice I have 5 and 10, and I have this 4, 1, 9, 6, 3, 8, 4. Then the next one, I got 2, 4, 6, 8, 10, then 5. Okay? You'll notice in the for loop, when it loops out, or when it does that for loop, it's basically catching that with the argument, which is a full array. And so you're not going to get an error on this one because of that. You're going to get some weird ending characters. So now let's do this. I want you to go ahead and you're going to print 3 arrays of the third array. But before you do that, you're going to have to initialize a third array. And I want you to put in the third array on line 15, declare an array called third array with odd numbers 1 through 9. Go ahead and do that. So put it on under line 16 maybe. So put your cursor at the end of that comment on line 15, and let's declare an array called third array. And in the array is going to be 1 through 9, odd numbers only. And then on line 20, you're going to call that function print array, and I only want you to print out 3 arrays only. 3 arrays only. And before you run it this time, correct line 17 and 18 to be back what it was before, which was 3 and 5. Okay, so I'll kind of walk around while you're doing that. Just make sure you get it. And this is just, again, an in-class exercise, something fun to do. Do you understand arrays? You understand how you can manipulate arrays? And all you're doing is, again, manipulating the existing array, adding to it a new array with the new values 1 through 9, 1 comma, 3 comma, 6. Yep. And then, 1 through 5, 7, 9. Then you're on that line. All you need to do on line 20 is do a print array to the third array. First array, second array. You got to do a print array to the third array, and then you're going to only print out 3 arrays. Okay, so on line 15, you're going to do an int. Third array, the name of that one. I'm going to put it all uppercase. Just make sure it's spelled right. Make sure you spell it right. There you go. And then you're going to do 1 to 9, and it's by 3. So it'll be 1 comma 3 comma 5 comma 7 comma 9. Then go ahead and run it. Cool. Good. You can help each other out too while you're doing this. Just I know your cubicles away sometimes, but cool. It's good. Yes, another thing in programming, I believe in team programming, where you can help each other. You'll be definitely doing that when it comes to your final app. You definitely help each other on that as well. Okay, so I'm going to go ahead and put mine in here real quick. And I'll just show you a little trick what I do. I already know what I'm going to, it's pretty close to what this one is. So why retype everything if I can copy and paste what I know it's going to be like. So this one's in third array. And it's 1 comma 3 comma 5 comma 7 comma 9. And then I'm going to do a print array. Copy and paste that one. And then just I'm going to copy that third array to this one. And run it. There we go. And that's what you should have gotten. Something like that. So again, you're just utilizing the power of that function, which is actually only technically 3 lines of code in that function. It for loops through that array and then kicks it out into a cout statement argument for the statement. Okay, let's exit out of that little tab, if you wouldn't mind. You don't need to save that unless you want to. You can save it, or you can go back later and save it. Oh, by the way, on this replet, if you didn't notice, by the way, when you're logged in as yourself on a replet, like I'm logged in as me, you're not logged in probably, but if you are logged in as you and you look at one of my examples, you can fork it to yourself and save it to your own replets, basically. And you'll rename it and it'll save it. Or you don't have to rename it. You just fork it to yourself and it'll save to your replets. And if I look at the overhead, I'll show you here on mine. When I click on my replets, it shows all the replets that I've created in here over time. And so you can, look at other people's replets, save them to your own replets, and that kind of helps you build your repository of examples, and not only your code, but other code from the class and other students maybe that that's helped you, possibly. Does that make sense? So I recommend saving as many code snippets to replets as possible to help you. And make sure when you're saving a replet, you name it to make sense of what that code snippet's doing. That way, at least, I don't really usually much play with the description, but I do pay attention to the name I put in there. That when I'm looking later, I can go, I have a replet for that. Because a lot of times people ask me for examples, and I'll say, I have a replet for that. Let me find it. And then I'll just send it to them via my phone or whatever. And I'll have to worry about searching for it anywhere else. Does that make sense? So replets can help you on building your tool set of repository of code bases. Because anybody heard of Steve Jobs before? One person? Oh, okay, 2 people. Anyway, he had a saying that said, all code is stolen. You ever heard that term before? Meaning, even though you think you have an original idea, more than likely you saw a program or talked to somebody about a program or whatever, your subconscious told you something that you saw or watched. Now you think it's yours originally, but more likely it's some component of something that you've seen or talked about doing in the past with somebody else. Make sense? All right, so let's look at the second example, which is this accessing arrays. As soon as we load it, this program is going to make use of what's called the setW function, the setWidth function, to format the output. It's going to make the output look really nice. We'll run it first, then we'll explain the code second. So let's go ahead and run it first. And notice here it runs it, and it gives an element column and a value column. So element 0 to element 9, and then values 100 through 109. Okay, in the include statements, the normal IOStream and namespace standard, but also you'll notice there's an include for IOM and NIP. That is used to do the set width for formatting output in C++. Using standard STW is also going to be used as well for the set width within the code. In the int main, just a simple 10 array, 10 space array, 0 to 9. The for loop is initializing those arrays, while I is 0 less than 10, it's going to keep incrementing, and it's going to be incrementing the 100 on the first loop, and then 101, 102, all the way to 109. The element column, you'll notice here, has a set width of 13. And what that 13 is referring to is it's referring to the set width of the value in this case. All right. And so you'll notice you have element and L, meaning it's going to be an end L. 13 in from the left is going to be 0, then 1, then 2, then 3, so on and so forth right here. Set 7, set width 7 on that one. And set width 13. So you have the set width 7 on the J and set width 13 on the N. And you'll notice on the loops here, on this for loop here, which is changing the array's value from element 0 to whatever, while J is equal to 0 and J is less than 10, J is incremented by 1. All right. So the first loop is going to be 0 all the way to 9. The first loop on N is going to be 100 because N0 is 100 on line 17, and 9 is 109. And then finally, the return statement, which says the code completed successfully. So what you're going to do with this one is you're going to change 10 to 20, if you didn't already see the comments. Then you're going to update the for loop on line 16 to 20, which is 10 now. And then also on line 23, you need to upload the array or update the array to change it from 10 to what? 20, thank you. So let's go and do that. Shouldn't take too long. And then once you do that, go ahead and compile your code again. This time it should go from 0 to 19 and from 100 to 119. I'll walk around real quick. Again, you're just manipulating an existing compiled version of working code to add a little bit to it, to learn a little bit more maybe, or understand a little bit more of how arrays work and iterations work. Good. Okay, after the on line 16, see where it says for I is equal to 0, colon, semicolon, I less than. After the less than symbol needs to be what? After the less than symbol. Right after the less than symbol. Yeah, you took that out. You took 10 out, looks like. You got to replace that with what? Yep, 20. Yep, should be it. Good job. Anybody else need help? Okay, again, we're just changing the index value of the array first to 20, and then hitting the 2 for loops to kick out the element column and to kick out the value column, both. Yes?
I've never seen that. Why is it saying using STD template?
What is what now?
Why is it saying using STD template? What is that?
Oh, this one right here. On the STD standard, actually, I'm not using it on this example. It will be used next week. It will be used next week. Yeah, it's just in there. It's not actually being used. STD is not being used. It will be though. So keep that in mind.
Well, I've never seen it where you include that after the header file because
Yeah. Oh yeah.
where you just used it.
What it means basically is this: STD, that letter STD or the characters STD, it can be used now in any of the CPP file. STD can be used for any function, both locally and global class or local variable, either one, local function, either one. But I left it in on purpose. I'm not taking it out because next week we're going to play with more on it because it really makes sense when you get into classes with that one. So yeah, good question though. So everybody get that one on the loops? Good. Let's close out of that and let's go to the simple functions. And this is a very simple function, but this one here is a function that has 2 integer values and returns a result. And in the int main, all it's doing is calling the sum of 1 and 99. And so if we look at the sum function, there's 2 arguments, int num1, int num2, and inside the function itself, we're doing a num1 plus num2 into a variable called num3, and then returning that to the main. So let's go ahead and run it. Should be a value of 100. What you're going to do for this one for your challenge, a little easy challenge, you're going to add a 3rd integer to the argument of the sum function first. All right, 3rd integer. And I'll let you name it whatever you want to. I'm not going to tell you what to name it, but it does have to be an integer. Okay, a 3rd argument to the sum function, which is right now, we have int num1, comma int num2. You have a 3rd one. Then, secondly, inside of the int main, you're going to add a 3rd number call to that existing cout on line 16. So go and do that. And this one should be updating also number 9. Should also be adding 1 more to that additional statement, or that sum statement, which is now just 2 variables, it'll be 3 variables. So you want to do that real quick? Again, you're adding first, in the function sum, you're adding a new argument as an integer. And then on line 9, you're adding to that argument, to that calculation, that new num variable, whatever it is you called it, that new int variable. And then on line 16, you're adding a 3rd number to that call, where it's going to be adding, instead of 2 numbers, 199, 3 numbers, whatever you put in that 3rd number is your choice. No, you're leaving everything as is. Leave everything like it was. Oh, that's fine. So this one here we're done with. So X out of that. Yep. We'll go back to the examples, and we're on the simple function one. Yes. So what you're doing here is you're adding another argument in the sum. It's int num1, comma int num2, comma whatever you want it to be. That's got to be. You just use the same thing that I've got going if you want. Do int num1 and num2, good. Okay, put in num4, it's fine. And then here on number 16, you need to add another number to the sum. That 1, comma 99, comma whatever number. And then here on line 9, you need one number to that too, because you only use num1, num2, num1 plus num2, num whatever you need that. What, num4? Is that what you needed? Yeah, so that needs to be a plus on that. And then, see what you got here. Yeah, that's good. Pretty good. Good, I'm going to run it. Okay, good job. Yours? Good. You want to help her on hers? Cool. Cool, awesome. Looks good. I just want to see the output as I walk by. It's great, just so you guys know you guys got it. If you need help, let me know. You got it okay? Okay. So again, a lot of times in programming, to use a Steve Jobs quote, you're also borrowing from yourself a lot, or you should be. I'm of the school of thought, why reinvent the wheel if you've already created something like that in the past? After you've been programming for a number of years, most all your projects that you get that are new, you can probably pull from the repository of your past projects 80% of what that project needs. You just have to add 20, really. If that's a hard program. That's a difficult program once you've been programming for a number of years, okay? Does that make sense? And so this little exercise helps you to understand that when you have a function or if you have a procedure or a class, keep track of those. And it's great to use Replit. It's great to use GitHub, which we'll get into this semester, where you can save your code and search it easy. So good job on that. Let's go next out of that. Last one is the math, simple math function. We'll look at that one. This one will use some C in and C out. It's a simple math that basically asks us to enter in number 1, number 2, sums those two, and outputs it. It's got a int. Well, first of all, let's talk about the declaration. It's got the declaration first. Before the declaration, it's got an encode statement for C math. It's got the declarative function, declaring the function int sum, and making a template for it basically in C++. And then in the bottom of your code, starting on line 31, is the actual function for int sum, which defines that function that's been initialized already at the top of your code in int A and int B. Int C equals A plus B and returns C. And inside the main, it's declaring two integers, X and Y, asking the user to enter in a first number, then a second number, then seeing out the sum of those first two numbers with the sum function. So let's go ahead and run it. Enter in the first number. I'm going to go ahead and put 12. Second number, I'm going to put 10. Sum of these two is 22. Pretty simple, right? So what I'm going to have you do for your addition to this one is on line number 7 and number 9 in your code, I want you to declare a function for divide, a function prototype for divide, declare a function prototype for modulus. And if you don't remember what modulus is a percentage symbol when you're in math. In C++ anyway, it's what it's used for. And most math, you see modulus as a percentage symbol. And anybody tell me what the definition of modulus is? A simple one.
Remainder.
What is it?
Remainder.
The remainder of a divisional statement. Right, correct. And so that's all it is. All right, so go ahead and declare a function for divide, declare a function prototype for divide, function prototype for modulus. And like I showed you earlier in the last few examples, I would use copy and paste to help you. So you could copy line 6 and paste on line 8 and 10 and just rename them to the names that you want them to be. Make sure the function names match what you need, which is divide and modulus. If you want to just call it mod, that's fine as well. Or div, that's fine as well. Whatever you want to call it, I don't care. And then inside the main, on lines 22, you're going to add a cout and code to multiply the values x and y. On line 24, you're going to add cout code for divide value of x and y. You're going to call that function for divide. And on line 27, you're going to call code and cout and code to the modulus of the values x and y. Okay, so we're going to do that. So if you start at the top bottom, it's going to be easier for you. So start with this line of code here first. Copy it, paste it here, rename sum here to divide, sum here to modulus, and then down here you're going to copy cout line 20, the whole line, and paste it on 22 and 24, and then rename it from sum of to what is it? Divide, the multiply of these two, and then to multiply or divide. This one actually should be, let me put multiply in there. This one here, by the way, on line 21, should be modulus. Is that right? I think I had multiplication first. I changed it to modulus. Multiply, divide, I put 3. So I'm having you guys only put in 2. Disregard line 21 comment, unless you want to do it, you can do it. So you just have to add another function up there. It's no big deal. So I didn't have you declare it up here at the top. And then at the bottom, make sure on underneath line 34 is where you're defining, on line 36, actually, where you're starting to define the divide function, and after 37, you're going to define the modulus function. You do not have to do the multiply function because I didn't have that at the top comment if you don't want to save time. But you'll get the gist of it. So let me walk around before I flesh mine in for you. We'll walk around and see how you're doing. Take your time on it. Help each other if you want. Once you figure yours out, you can help your neighbor if you need help on it. No, you're good. No, divide's good. Modulus is good. Oh, you got your 2 declarations. That's good. And then now you're going down here on line 20. Remember, copying that line to code. Line 20 is a CI statement. Whole line code. In case that was 22 and 24. You just have to rename where it says that should be instead of multiply, it should be. Yeah, the comment should be modules. I'm sorry. So some of these 2 would be modules of these 2. So some of the modules. And what's the function name for that? Instead of sum, it is that. Same thing on that one. And you have to add in 2 more functions below. So lines 36 and 38 look just like lines 31. Copy paste that. And rename your function and put the mathematical operator. What? The modulus, yeah, the remainder is fine. That's fine. You can do that one. You got modulus and you have divide. Good. And then you need to add in 2 more functions down here. So lines 31 through 34, you need to copy those lines of code, 31 through 34, paste them on lines 37 and 38. And rename the functions and put in the right calculation. Good. Yeah, it's right there. Name sum to what is it, divide. And then we do the calculation. Plus 2, yep. And then the modulus is the percentage symbol. Got it? And then that should do it. Then check your syntax here. So you make sure you got semicolons in there. So you got divide. Modulus, good. You're spelling this is just like this. And then make sure the spelling of your functions are the same as how you define them. Spelling has to be the same too. Yeah, just make sure you correct it downstream too. Make sure your spelling is correct on all yours. Yes. Okay. Right, so you added your divide, you have your modulus. I would rename instead of modulus on your function name, I would call it mod. Let's call it mod instead of modulus. It's going to have a naming conflict. The actual word modulus. Function. You get that? Yeah, call it mod instead of modulus throughout. Yeah, because it's a reserved name. It's a reserved name. I think I mentioned it up there, but I did not hammer it. So there we go. So yeah, make sure that you're not using a reserved word modulus, because it'll say ambiguous or unambiguous or something like that. It's not there. You use modulus for the function name and entry. Okay, here. Good. Great. Good job, everybody. Awesome. Well, I won't type mine in. Looks like everybody's got that one. Basically, the only one I didn't hammer away was on this modulus one. If you were to have used modulus, look, I'll do that one only on mine to show you the error that you would have gotten. Some of you figured out probably whenever you typed it in. So I'm just going to do the modulus only. And let me do. There we go. Should have said error referencing in the int main. It tells you exactly what it is. Referencing to modulus is ambiguous. And so anytime you see the word ambiguous and you know you have did an initializer, you're using a reserved word, basically. So I just change it to mod instead of modulus, and that should fix it, correct? There we go. And I did not add the values here. There we go. There we go. All right, cool. So that's that. That's the examples. Go next. And again, I recommend saving those to your own later on when you're playing with these at home. The assignment for this week, I've already got it on the overhead. Let me go over real quick with you, and then we'll be done with the assignment portion and in-class portion. Lesson 2 is a program calculator for the area of rectangle is already done for you. In fact, if I run this as it is right now, it asks me for the length of a rectangle, which I'll put 12. The width of a rectangle, I'm going to put 12, and it says the area of rectangle is 144. Your job is to come up with the code and the output for the parameter of a rectangle. And I did put a link in here, by the way, to help you at the bottom of this. If you go to that link, it just talks about what a parameter is, how to calculate it, or how to sum a parameter, basically, which is pretty simple. So the challenge, though, for you this week is to, once you've done the rectangular or parameter portion, and that's working, the challenge is to declare variables for full name and email, have the user see in their full name and email, and then update the sample output to look like the following. My name is Steve Jobs. My email is steve@apple.com. And by the way, if you've already done this, you can reopen up your Replit and update it too. So you can open up one that you've submitted already. The area of a rectangular is, which is done for you initially, and then the new one, which is required for your assignment, the parameter of the rectangle is. So this is a challenge, as I mentioned earlier tonight, will be in each one of the assignments from here on out. The challenges will get increasingly more difficult for you, which will help you kind of, tackle it, but also be creative. It won't be so difficult you can't do it. It'll be just a little bit more work, basically, to figure out how to do it. That makes sense? And so once you get finished with the required, which is parameter, I would say go ahead, if you have time, which you should, do the challenge. If you need help on what a parameter is, go to that link on the mathisfun.com geometry parameter, which talks about getting a parameter, I believe, for rectangular, as in there, an octagon and 4 or 5 other shapes you can get a parameter from. It's pretty simple. Basically, just plussing together all side lengths, whether length and width both of all side values, basically, of that object. Question on the homework. Once you're finished and you've submitted the homework, I will get a prompt on my end to say completed. If it looks, like you've done the work, I'll say completed. Again, challenge is not required, but I would recommend it. Questions on the homework, the parameter homework. Okay, cool. What else I want to mention? Oh, before we're done, I wanted to mention, see what you guys think about this. Review questions, I'll mention that. Go over there, finish your review questions. Do these offline though, before you submit submit yours to the sheet here, to the text entry or file upload. If you do a file upload, it'd be like, doing a Word document, upload it, or doing text pad or whatever. I have students do it on their phone, then they just copy and paste it later. That's fine, however you want to do it. Okay, this is the fun part of tonight before we're over. Anyway, I got approved last year to do, anybody heard of a hackathon before? Anybody heard of a hackathon in here? Hackathon has to do with, a lot has to do with coding and getting a problem like we've been doing tonight a little bit in a grander scale and trying to figure out that problem via code. Well, they have Major League Hacking is an official student hackathon league, and we've been approved to host one in March. Here's the award from Georgia Tech that they won in 2017. And when we'll have our name up here at the top, and ours is going to be called Rock the Hack is the name of our hackathon. Rock the Hack. Yeah, kind of cheesy, but I came up with it. Anyway, it sounded better just RVC Hack or something like that. Basically, you can go to this website. It's mlh.io. I'll post it in our announcements later, but it goes over what MLH is, what the hackathon session is, and the season's all about. If you're interested in being part of it, we're creating a teams right now, and you can just read up on it, see what past hackathons have done, watch the videos, and then shoot me an email and say, hey, I'd like to be a part of that, because it's going to take place in one day in March. And basically, it's going to be usually like on a Saturday or something in March. And you will compete with other colleges from around the nation on a problem they'll give you. You'll have no idea what the problem is. I won't know what the problem is. And then you try to figure it out with code and with brainstorm skills and figure it out, basically. And so it's a lot of fun. I've been in a number of them over the years. It's a way to learn coding too, but also it's pretty cool to compete with colleges like Princeton, MIT, and Harvard, I think. And so, we do pretty good, by the way, as a community college when it comes to most people aren't aware of this, but in our debate we have here on campus, we debate against big school, big colleges, universities do quite well. And I think we do quite well as well in the hackathon as well. I know we can. You guys are pretty sharp, and all it takes is analytical thinking, problem-solving thinking, which you all have, and be willing to have a free Saturday to eat pizza and pop and Mountain Dew, whatever else it is, just keep you stay awake for an entire day. And you do learn a lot. You really do. And so, again, as a coach, we're given very little information on the hack itself. We're given a lot of information on tools you need to fix the hack, and that's good. So if you sign up for it, you'll have a couple months to prep for it, basically, a whole bunch of learning things and modules and challenges and stuff like that. And so personally, hacking is, I think that hacking has got a bad term over the years. Really all hacking is investigating how to fix something, in my mind. That's why I like hacking. And the term we use in college is ethical hacking. And so all that means basically is you're hacking to learn how to stop an attack, but also you have to learn the dark side on how to start an attack, because you can't stop an attack if you don't know how an attack is started. And so you do learn both sides. But the difference is you're learning how to eventually use those analytical skills to, get a job, and whether it be in programming or whether it be in, Homeland Security. Or, by the way, just FYI, the government and those powers that be do look at these type of events, and for the student pools in these type of events to hire for future Homeland Security analysts and CSI analysts in the area of coding and hacking. And so, which makes sense. And so the way they hire, by the way, in those areas is generally not in monster.com or dice.com. They generally just come knock on your door on a Saturday and talk to you for a while and hire you on the spot. Is generally how they do it. And so, but they find these as a testing bed, these hackathons as a testing bed for students like yourself that you have skills maybe you don't know yet, possibly. And so the hackathon kind of helps you with that. So look at hackathon. I'll post it in the announcements, mlh.io. By the way, anything geeky today always ends with an IO. In fact, I'll teach you this semester how to create a GitHub webpage, which ends in IO, which is totally free to do. And so anyway, avail yourself to this. I'll post in the announcements. I won't talk more about it. I'll let you peruse the website, and there's tons of videos and resources. And what I'll do is next week, I'll give a formal push to this and say, okay, if you're interested, go to this site, sign up here, because we need to get our group or our team by the end of middle end of February. It has to be locked in. So questions on that? I can answer quick questions on the hackathon if you want. Yeah.
I was just wondering, so how big are the teams?
How big are the team? Yeah, that's a good question. The teams actually are pretty fluid, depending on we can have as little as 5, and we can have as up to 20 or 30. So they're pretty fluid. And what's cool about having more is we have more of a chance of winning or something, winning something anyway, the more people we have. But yeah, that's a good question. There's no real, if it goes beyond 5, they generally split you up into different groups, which is fine. And no, that's a great question. So there's really no limit. No, there's really not been a problem in any school having to like cut off the people applying. I don't think we'll have that problem either. I mean, if we can get 10 students do this, that would be awesome. If we get 10 students from all Rock Valley sign up from all my programming courses, that would be great. And so out of this class, if we could get 2 or 3 or 5 of you to sign up, that'd be awesome. Yeah.
The actual hackathon, do we meet here at Rock Valley?
Yes, we do meet here at Rock Valley, and the rules of it is which makes sense. You have to be in a governed area during the hackathon to where you're not kind of being rogue out there doing something. But we do feed you and all that fun stuff, and so you little prizes. Even though, yeah, question here on campus, and it's going to be in March sometime, and more than likely, I think we're shooting for after spring break, which I think our spring break's like the 2nd week in March, I believe, something like that. I think that's what it is this semester. Yeah.
Just on the news today, you were talking about the Internet of Things last week. Just so somebody came up with an idea for shoes for the elderly, and when they fall over and they don't get up, it calls 911. But you're just talking about Internet of Things.
So is it a wearable though?
It's in the shoe.
In the shoe. Okay.
Embedded in the shoe.
That's cool.
Yeah.
That's cool. Good question. Yeah, that's great. Any other questions on that? On the MLH? Yeah.
So what would coach?
Do I know?
Or is it like would you oversee us or like?
Yeah, I wouldn't be the only one. I know I'd just be the main facilitator for it to give you guys all the tools you need prior to learn. But then during the event, as an instructor, I can't help. I can give tips, and I can give what they tell me I can give. That's about it. But you'll have time to play with it between now and then. On you'll have an idea of, you won't know what type of attack, but you'll know all the different types of attack it could be to be prepared. If that makes sense. So they go over all different types of scenarios up to that point, and then help you with tools to learn. Like an example is taking down a web server is one of the examples. Hackers take over websites and take them down. You might have heard in the past, or infiltrating an email server, or getting backdoor into a website to log in through what's called SQL scripting. You'll learn about that. And so a lot of stuff you learn, you probably won't learn in school. You won't learn in college. And that's why I think it's great too, because it's techniques and skills that you technically only learn in a hackathon. They don't generally teach it in a 2-year or 4-year college, if that makes sense, in this setting anyway. And so it's a kind of a whole new ecosystem just for colleges You don't get credit for it, but it's a great experience, really good experience. And it's a lot of fun. So great question. Any other questions before I let you go? All right, so do me a favor before you head out. If you could click on your Apple logo on your Mac and then just tap restart. These computers do have deep freeze like all the other computers, but I generally try to restart it for the next sessions that come in. And you'll do that every session. Just come in and do a restart. And remember the podcast is available for you in week 2 that you can forward fast to watch. And that's it. If you have any questions, come see me. Otherwise, see you next week. Be careful out there. It's slick in places. Almost freezing.